So again, just reiterate. So we are on this refactoring guru website, beautiful website, facing this first pattern from. If I go here, design patterns, we can see design patterns. We have catalog of patterns, list of 22 classic design patterns grouped by their intent. Factory method. I already described the factory method in the previous section of the video. And yeah, so the solution like how to implement this pattern, they propose us to make the factory method pattern suggests that you replace direct object construction calls using new operator which calls to a special factory method. Don't worry, the objects are still created via the new operator, but it's being called from within the factory method. Objects returned by factory method are often referred to as products. So we have some kind of logistics like application, like client code, which has some method plan delivery, and within this plan delivery method we will create some kind of transport. But notice that we do not use like new operator. We call this function create transport, and within this transport object creation is must be defined, but it's like abstract create transport. We don't, then transport itself is abstract thing like interface, I would say, which can be either truck or ship. So and then so this is like how they propose us to do, like defining some kind of interface or abstract class, and then use inheritance, Java for example, inheritance to inherit from logistics and define such kind of road logistics and sea logistics, which are subclasses of this superclass. And within these subclasses we define this create transport method. So for sea logistics it returns new ship, and for road logistics it also defines overrides or implements this create transport method, creating a new truck. So we can see that we don't actually see, but the ship is like a subclass of transport, and truck also a subclass of transport. So yeah, that's basically it. So we define some kind of interface, we define the implementation interface like factories. Each factory creates their transport regarding like road is hugely coupled with truck, and C usually coupled with the ship. Subclasses can alter the class of objects being returned by the factory method. So we have like so at first glance this change may look pointless. We just move the constructor call from one part of the program to another, so not constructing here, for example, new ship or truck, but we move in the actual creation of transport to the subclasses. However, consider this. Now you can override the factory method in a subclass and change the class of products being created by the method. There is a slight limitation though. Subclasses may return different types of products only if these products have a common base class or interface. Yeah, so it's like a limitation from a, because for example when we are dealing with statically typed languages, then we of course have such a limitation that subclasses, these truck and ship, they must implement the common interface transport, which can be either interface or abstract class, we'll see. Also, the factory method in the base class should have its return type. The factory method in the base class should have its return type declared as this interface. Yeah, so create transport actually will return the transport as an interface or abstract class, not defined in the actual implementations, like ship it and truck. So here we are dealing with abstractions, and here we are dealing with concrete implementations of this truck for specific logistics classes. So yeah, as I said, they propose us to define some kind of interface transport with deliver method as a abstract method deliver, and yeah, this abstract method, of course, it doesn't have implementation within it. And then we have ship and truck. So it's like yeah, interface transport, and we have ship and truck. They all, this truck over implements this deliver method from the transport interface, and within this method we will deal with the trucks delivered by land in a box. I mean, like, yeah, so, and for ship we define or implement deliver method to deliver it by sea in a container by ship. All products must follow the same interface. They mean that we have ship, it should implement this interface. Like in Java, it would be like class ship or maybe interface ship, but okay, suppose it's ship like class, it will implement this transport interface. And then we have truck, which also implements this transport interface. For example, both truck and ship classes should implement the transport interface, which declares a method called deliver. So mention that these methods have the same name, right? Deliver. It's really crucial, so that the language, for example Java, will understand that we are overriding or implementing the deliver method. It's like a just identification of a method or identity of a method, or I don't know how to call this. So each class implements this method differently. Trucks deliver cargo by land. Cargo, it's like some of the products within, not products, but yeah, like products for customers, like yeah. And ships deliver cargo by sea. The factory method in the road logistics, factory method in the road logistics here, create transport. The factory method in the road logistics class returns drag objects, whereas the factory method in C logistics class returns ships. Here it is. C logistics create return new ship, and road logistics creates a new truck. So as long as, yeah, so we can see this logistics app, it creates some kind of transports. You can see that it creates logistics apps is just like client code, which uses some domain, right? And now it depends on abstractions or on transport, as solid says that we need to, our modules, our components, our code depend on abstractions, not on implementations. It's great. So logistics app will depend on some kind of abstract transport interface, and this logistics app client code doesn't really even need to think about which transport it is. It can be truck, and can be it can be ship, it can be truck, or maybe even in the future it will be like galactical space submarine. I don't know how to, so maybe we will define some kind of other transportation. For example, by now we can see that helicopters, right, or planes. So So if this logistics app uh, will depend on abstractions, on abstract classes or interfaces like transport, it's really really cool because this can be unchanged. The logic within this logistics app client code can be unchanged, and other things like dealing with implementations like these truck class, for example, or road logistics, they will define the actual implementation, and then these can be changed with the code can be changed within these classes, and logistics application code will be in this case not changed because it depends on some kind of abstractions on logistics class, which is maybe interface or abstract class. But we can of course do it using not inheritance but composition, delegation, and trait or interface implementation. So yeah, as long as all product classes implement a common interface, they say that product classes is like product class, right? We have product class. Where is this product class? I think they mean by transport. Transport is the product type. So as long as all product classes implement a common interface, you can pass their objects to the client code without breaking it. So it's like powerful thing that we can actually pass whenever we have a reference to parent class. We can pass actually the object of subclass. With Java, for example, Java allows us to do this, as well as Scala and C# and stuff like that, and C++ and all of the languages supporting this classes inheritance. The code that uses the factory method, often called the client code, doesn't see a difference between the actual products returned by various subclasses. It directly what I was speaking about, that the client code will actually deal with abstractions rather than implementations. So they say that client code, often called client code, doesn't see a difference between the actual products returned by various subclasses. Thus it can be unchanged, it can be unchanged, this client code. So the client treats all the products as abstract transport. The client knows that all transport objects are supposed to have the deliver method, but exactly how it works isn't important to the client. They say that. So we can conclude that the client code can be unchanged because it hugely depends on abstractions rather than implementations. So it's a really, really powerful thing. So structure, we have creator, some operation, product. Okay, I don't really a lot of okay. So we have creator. This creator has some operation method. It says product p create product, and p like product do stuff. So this is like client application code. It only depends on abstractions on product. It only knows that we can actually create product, and product can do some stuff, and that's basically it. It doesn't really know which product is actually be created. So we have creator class or component. We create product. Yeah, so and then we have for creator we have concrete creator B and create creator A. So here in concrete creator A we return new concrete product A, and concrete creator B create product B, and creator depends on interface product and not on actual classes. And within this product we have only method do stuff, and we have some of the implementations, like we have product product in this example, it's of course our transport interface, and it has a concrete product A, a concrete product B, like transport truck and transport ship. So let's read a little bit. So the product, so this is like first, the product declares the interface, which is common to all objects that can be produced by the creator and its subclasses. So we have this product, and now we can see that we have only two of them, but but this is really powerful thing, because we can define, of course we can implement a lot of other products in the future when the requirements, when the imagine for example this logistics company will be huge enough to accommodate more ways of delivering. Maybe we don't even imagine how the future will be like, right? So it'd be, for example, transportation between the maybe stations between Mars, maybe AI, maybe the humanity will do AI creatures to live in Mars, right? And then we have Earth, if we survive on this Earth. If we not be bombarded with atomic weapon, we can actually survive our Earth, and we can, for example, create some kind of AI that will live in the Mars, and then we need to some kind of new logistics, right? So this application will be flexible enough to accommodate new concrete product. For example, I don't know how to call this, submarine transportation, I don't care about that. So the second is concrete products are different implementations of the product interface, right? So they are different. So we have product and we have concrete product A and product B, which are different. Then they say the creator class declares the factory method that returns new product objects, so what does this mean is that we have this create product, right? Create product method. It's important that the return type of this method matches the product interface, right? So we can see that create product actually returns product. This colon and product means that this is a return type. For example, in Kotlin or in Scala or in Rust, we actually specify the return type like that, and not like in Java at the very beginning of the method. So yeah, it returns some kind of product, which is here, which is interface, abstracting, and yeah, it's important that the return type of this method matches the product interface. Then you can declare the factory method as abstract. Declare the factory method as abstract to force also. Okay, so the factory method, they say that we can factory method, they mean creator. This creator is a factory method class, and we can declare it like abstract to force all subclasses to implement their own versions of the method. As an alternative, the base factory method can return some default product type. So we can actually say that we will, if the subclass does not define the create product method, we can somehow do like some kind of default implementation. So they say that we can actually do this creator not interface but abstract class, and within the create product we can actually define some logic, and in this case this will be not abstract method but concrete method returning some default product, and then concrete create concrete classes can override not implement, but override the object, the method within the creator, within the abstract class. Note, despite its name, product creation is not the primary responsibility of the creator, right? So they say that this class creator, and we have this create product. Product creation is not the primary responsibility of the creator. Usually the creator class already has some core business logic related to products, which is this one, some operation.